Rahim. Uh, let's start our class. Today, our class is related to protection of transmission line, uh, impedance, or the distance today. Okay, so this is our today topic. Okay, so uh, in the last class, uh, we have discussed the distance relay, how the distance relay works and how it measures the impedance. So let us continue our discussion. The next topic is the reach of the distance relay. As I have already discussed in the last class, that the distance relay measures the impedance from the link point to the fault point. And this impedance is positive sequence. So on the other hand, ground distance relay, if you use, then it is based on zero sequence impedance. So whenever any distance relay we put in the circuit, then in that case, if I consider for example, let us say bus A, which is there, and there is a line connected between A and B, and we put a distance relay here R, which is also fed by the line, which is also here. So obviously, whenever fault occur on the line, the distance relay just measure the impedance, and when the measured impedance is less than some set value of the impedance, then the relay operates. So the distance up to which the distance relay measures the correct value of the impedance and provides operation. So further tripping to the circuit breaker. So the area or the portion that is known as the reach of the distance relay. So reach means nothing but the area up to which the distance relay is capable to sense the fault whenever it occurs on the transmission line. Okay. Now we know that the relay is always connected, as I have told, uh, I have told you on the secondary side of the circuit. Okay, relay is connected to secondary side and the PT or the circuit breaker. So we need to transfer the impedance from primary side to the secondary side, because the impedance seen by the relay, that is different, and impedance on the other hand on the primary side, that is also different. So if I want to just convert this impedance from primary to secondary side, then we need to use the equation. So for example, let us assume that this is the line value, and let's say it is 5 plus j 15 ohm. So maybe if you convert this value in polar form, it may be something 15.5 angle, 15 by 15, so 10 inverse 3, maybe around roughly 76 degree. If the CT ratio is let's say 1000 by ampere, and if the PT ratio is, let's say, 132 kV by 110 volt, so then this impedance uh, of the line is called the impedance on primary side. Okay. So now whenever we connect the relay, whatever impedance that is seen by the relay, the impedance is known as secondary side impedance. So obviously we need to convert this impedance. So we need to find out what is the impedance seen by the relay. So the impedance seen by the relay, if I call it Z secondary right, then as I have told you, the equation is given by the secondary equation of the Z primary into the ratio of the ratio of the current transformer. So is current and the potential transformer. So here we have the Z primary into CT ratio divided by the PT ratio. Okay. So this Z primary, that is the value 15.5 at an angle of 76, and into CT ratio. So that is equal to 1000 by 1. Okay. So, and whole divided by PT ratio, that is 132 kV. So here is the value is 132 kV. So 132 into 10 raised to the power 3 divided by 110. So whatever final value comes, that is also in ohm, but this value is the secondary value. That is seen by the distance relay R. So that means whatever we solve the example, or whenever we look into the practical field, the impedance of the line is given. So impedance seen by the relay that can be calculated using this equation. Okay, this is the equation. Okay, Z secondary equals Z primary into CT over PT. So we have discussed reach of the relay. So there are two other phenomena also we need to discuss, that is known as uh, the reach of the relay. So reach means the area or the portion up to which a relay is able to sense the part. Based on this, we have another two important definitions. One is known as overreach, and the other one is called the underreach. Okay, overreach and the underreach. So what do you mean by the overreach? So again, let us consider the same example. Here we have connected a line A, a line between A and B. We have another bus C. So we have another line. So this is the line 1 and this is the line 2. Line 1 and line 2. And let us assume that we have a relay R connected, which is a distance relay. So we just give the input from the CT and the PT. So these are the CT and PT. So first zone of the distance relay is 80%. So this is R1. After some time delay, we have a second zone. So this is the R2 and so on with some time delay, that is the R3. So now, what do you mean by the overreach? Okay, that is the question. If fault occur somewhere here in line section to say at point F1, okay, this is the fault. So if fault occur at F1, then obviously relay R will look at this fault in the second zone. Okay, relay R. So second zone, that is the at a time delay, as we have put in the previous class, that 300 millisecond to 600 milliseconds. So any part occur at F1, then relay R does not see this part in the first zone. Okay, so it does not operate, but due to some reason, due to some problem, if fault occur at F1 and relay R looks or sees this fault in the first zone, right? So the first zone, and if the relay in the first one operates instantly, so if relay R operates the fault at F1 instantaneously, then that is known as overreaching of the distance relay. Okay. So overreaching is defined as the tendency of the distance relay to operate beyond its zone of operation protection. So here is this case in the second zone. If any part occur in the first zone, then uh, first zone, then the relay R has to operate instantaneously. But if any part occur beyond first zone and if R really operate, then that is known as overreaching of the relay. Similarly, let us see what is underreaching of the distance relay. So underreaching means if part occur within, so this is the first zone area. So if any part, let's say a part occur at point F2, F2. So obviously this part is in first zone, so relay R has to sense the part, this part, and it has to it has to operate. Okay. But if relay R does not operate, or if R is not able to sense the part of F2, then that is known as underreaching of relay. So underreaching of the disk relay is defined as it is the tendency of the distance relay to remain in blocking condition or to remain in inappropriate condition even though the fault is within its zone of protection. So this is known as underreaching of the relay. So now this overreach or underreach, that is mainly because of the fault. So magnitude of the fault current. So we have already discussed that fault can be asymmetrical in nature or it can be symmetrical in nature. So there are two types we can classify the fault. So whenever usually fault occur, it is asymmetrical in nature, and this asymmetry depends on decaying DC component, decaying DC component. Okay, this is the so this decaying DC component is responsible for whatever whether relay overreach or the relay operates correctly. So the value of this decaying DC offset in the fault current that is responsible for this overreaching of the relay. The ratio of DC offset of the fundamental frequency component that depend on inset at which fault occurs. So if I just find out what is the value of the DC offset, and then if I find the fundamental frequency component, the value may be current, then they depend on instant at which fault occurs. Uh, uh, Switching this instant value we are talking about. So, however, the instant of fault we cannot predict, so it can not be in the user set uh, or on the decay or DC's offset at which rate the DC the which at which rate the DC offset decay, that depend on X by R ratio of the system, and for modern system X by R ratio is very high. However, the DC offset is present only up to first few cycles, that is 4 to 5 cycles, and this distance relay operates instantaneously only in its first zone. So it operates in the time decay in seconds and in third zone. So second and third zone of the distance relay are not affected by the transient overreach or decaying DC component. So whenever the distance relay overreach, and if that phenomenon lasts only for the first few 4 to 5 immediately after the occurrence of the fault, then this type of phenomena is known as a transient overreaching of the distance relay. So the distance overreach disappear after a few cycles. So second and third zone of the distance relay are not all affected by the transient overreach. So how to find the percentage transient overreach? So that can be obtained using this equation. Okay, this is the equation. You can easily find out the value of the percentage for the distance relay. So in this case, Zx that is maximum impedance for which the relay operates with an offset current wave for a given adjacent, and Zy is the maximum impedance for which the relay operates for symmetrical current for the given adjustment of the value of Zy. So using this, you can easily find out the percentage overreach in any distance relay. Okay. Then it is also true that the angle phi, which is tan inverse x by r, increases, the transient overreach also increases. And for our long UHV and EHV line, the inductive reactance, that is the high voltage line and ultra high voltage line, the inductive reactance is very high. So obviously the spacing between the conductor increases due to because of the utilization of the bundle conductors. So the value of the transient overreach also increases. Now with this background, let us see what are the different type of the distance relay characteristics that is available in the market. There are many type of the characteristics available so far as distance relay is concerned. Okay, so which type of characteristic we have depend on the application. Suppose if I want to use any distance relay for the protection of shorts line, then we have to go for a reactance relay. If I want to protect a long EHV transmission line, then we should go for MOHO, maybe further quadrilateral or some other type of distance relay characteristics. So it depends again on the application. So let us discuss different type of characteristic. So usually there are 6 characteristics. It can be more uh, let let us discuss it. So the first characteristic is known as impedance type distance relay. So if I use a distance type distance relay, then this characteristic is shown here. Okay. It is the impedance relay distance relay characteristics. Uh, this first one. This is the characteristics for the distance relay. Okay. Uh, you can see this is the circle on uh, the RX plane. Now the important point is you can look at, if I just draw on the side the this RX plane, then line to be protected or connected between two buses, that is somewhere here. This is A and B. Okay, so this is line, uh, trans the transmission line. This is A and this is bus B. Okay, so if I draw the circle from this point, say this is your 80% region. Okay, this is the 80% region. So I have to draw a line, a circle. uh, uh, the 80% region of this circle, uh, the 80% of this of the line will be covered by this circle. Okay. Then if I uh, draw, if I extend this line vector, then any fault occur on the reverse side of this relay or the bus. The impedance relay also detects or sense this type of default. This is the negative side. Okay. So to avoid mal-operation of the impedance relay on reverse fault, normally okay, this is the reverse side. So to the normal in actual field, what we have to do, we use the directional unit. So this is nothing but the directional characteristics of the relay. So we have a directional characteristic like this. Okay, uh, this is the line. Okay, and now the relay that is not going to operate on this region. Okay, this region, relay should not operate on this region. This is the directional characteristics of the impedance relay. Now, you can also see here on the impedance characteristic, if any value above on this side, we have a positive torque region, that is uh, this one. Okay, and the value below the characteristics, uh, I told you this side, this one is the negative side, and we have the angle theta, so that it is the theta, nothing but this is the angle of the impedance Z1. Okay, and this is the theta of your K1. So this theta is nothing but your characteristic angle theta of the distance relay. Okay, this is the theta. Uh, this is your K1. Okay, so this is also called the impedance characteristics. This type of characteristic is nothing and is not used in the field, because whenever you use it, you have to again further use it directional relay along with the impedance relay. So this is the biggest disadvantage of the impedance type distance relay. The next type of the characteristic that is known as the reactance relay. Okay, so this is the characteristics of the reactance relay. If the fault occur with any value of the fault resistance, then this type of relay is not affected by the phenomena. We will discuss later on what is the effect of fault resistance on the fault resistance on the performance of uh, the distance relay. So you can look at here the characteristic of the reactance relay. The characteristic angle theta is 90 degree in this case. If the theta is not there, we can use uh, Now, if you look at here and at any value beyond this line, below this line, that is the mm, below this line, that is this the angle. So the relay will operate. Okay, this is the this is the line. Okay, below this line, the relay will operate. At any value above this line, the relay will blocks. Okay, so this is the block region and this is the chip region. Okay, it is shown by the shaded portion. Now, when you consider it measures only impedance reactance. So this point, this line is nothing, but you can say 80% of the X value or inductive reactance part of the transmission line. Okay, so the 80% part of the transmission line. Okay, X value, reactance value. So whatever primary impedance of the transmission line is given, you also take 80% of X. That is nothing but this value, set value X of the reactance value. Okay, so this is the X set of the reactance relay. Reactance relay is normally used for short transmission line. So when we have a feeder uh, whose length is very small, at that time we can use the reactance relay, because in that case the fault impedance is very high. So if I use reactance relay, then there is no effect of fault impedance on the reactance relay. But the biggest disadvantage of the reactance relay is whenever any some other phenomena occurs like power swing, then this relay is very prone for mal operation, and hence uh, this type of characteristics are not used normally for long protection of long EHV and UHV lines. Okay, so the third type of the characteristics is known as MOHO or admittance relay. Sometimes it is also known as angle admittance relay. So it is basically the modification of the reactance relay. Okay. So after such a discussion, now let us discuss that what are the different type of the distance relays. So whenever I consider the distance relay are basically classified by uh, two units. One is known as phase type distance relay and other is known as a ground type distance relay. So for example, if I have a transmission line connected between two buses, let's say A and B. Okay, this is A and this is B, and we have three conductors, say R, red, yellow, and blue, and we have the relay located here. This is the relay. This is your relay supplied by CT secondary and PT secondary. Okay. So this type of the relay, when we talk, it can be a phase type relay, phase type distance relay, or it can be ground type distance relay. Okay, phase type distance relay and ground type distance relay. So when I consider uh, phase type distance relay, the phase type distance relay is capable to take care of the line of the fault. So it can be RY fault, okay. Uh, it can be YB type fault, or it can be B R type fault. So any type of this line to line fault, either uh, red yellow, yellow blue, or blue red, the phase distance relay detects and it gives further signal to circuit breaker. It is also capable of the phase type distance relay and also capable to take care or detect triple uh, line faults, means line to line to line fault. So this is say red yellow blue fault. So any type of this phase fault occur uh, which do not involve ground and phase distance delay, that detects and further gives signal to the circuit breaker. So far, we need for each phase we need one phase distance relay. Okay, so if I have a relay here on this side at bus A to protect this signal, uh, s- uh, uh, to give signal to the transmission line, then I need three phase distance relay for each one for each phase. Okay, three phase distance relays. So three distance relay are required to detect or take care of either line to uh, line fault or triple line fault. Similarly, ground distance relay is capable to take care of line to ground fault. Okay, so it can be red to ground, it can be white to ground, or it can be blue to ground. So any type of line to fault occur, then ground distance relay detect and uh, take uh, take care of this and further give signal to circuit breaker. Similarly, it can be capable to take care of double line to ground fault, means red yellow to ground or yellow blue to ground or blue red to ground. Okay. So again, three line to ground faults, double line to ground faults, the ground uh, distance relay take care of this thing. If triple line to ground fault occurs, which is very rare because it involves some impedance or resistance, then ground distance relay will take care of this too. Okay. So so far at this point at bus A, if I want to protect the single circuit transmission line, then along with three phase distance relays, we also need three ground distance relays. Okay, so three ground distance relays. Okay, so that means if I want to protect single transmission line, then I need total six distance relay, three phase relays, and three ground relays at one bus. Okay. So I use another distance relay here at bus B, and then at bus B also for this relay again three phase relays, phase distance relays, and three ground distance relay are required. So total 6 units are required for to protect one single transmission line. So six for bus A and six for bus B. So now we consider phase relays and ground relays, and as I have told you, phase relays are meant for phase fault and ground relays are meant for ground faults. Then we have to provide then we have to provide some quantity to the phase distance relay and some quantity to the ground phase, because here whenever we install the relay we give input to the relay that is only voltage and current. So whenever we give voltage and current relay, depending upon some calculation, it has to convert it to the impedance, and that impedance is known as measured value of impedance. And then it compare this measured value of impedance, okay, the current and voltage value, it has to be converted to the impedance, and it compare this measured value of impedance to the set value, and if it is less than that relay operates, otherwise the relay will block. In this case we have started our discussion. Okay, let's summarize the whole lecture. We have started our discussion with the reach of the distance relay. We have discussed the underreaching and overreaching of the distance relay, and then we have discussed the different characteristics of the different type of the relay available in the market. Okay, so finally we have concluded that MOHO type of distance relay and are widely used for the protection of long EHV and UHV lines. And then we have end our discussion with a different type of the relay, that is phase type relay and the ground type relay. And I'm going to stop here. Then in the next lecture, we will further continue with the phase transmission phase at the ground type distance difference. So that was all for the moment. Thank you.